Imagine a world where red-hued landscapes stretch as far as the eye can see, where mysterious valleys and towering peaks beckon us to explore, and where the possibility of life beyond Earth tantalizes our imagination. Welcome to Mars, the enigmatic neighbor of our home planet. In this captivating video, we delve into the extraordinary quest to uncover the secrets of Mars and unlock the ultimate question: could life exist on the red planet? For now, though, scientists aren't ready to conclude that our vermilion neighbor was once inhabited. Just about every alluring hint of biology could also be explained by some as yet unfamiliar aspect of Mars's geology or chemistry. There's just so much we don't know about how the planet works and how non-living phenomena could be masquerading as life's fingerprints. This is an alien world that we're looking at. And so who knows what we haven't even thought of, says Curiosity Deputy Project Scientist Abigail Freeman of NASA's Jet Propulsion Laboratory. Is there life on Mars? In our fantasies, Mars has almost always been inhabited, if not by aliens, then at least by our future selves. But spacecraft observations quickly snuffed out dreams of advanced civilizations, seasonally flourishing vegetation, or even benign, gelatinous vegetarians. We don't have anything glowing. We don't have anything saying hello. We had no ray guns when we landed there, says Andrew Steele of the Carnegie Institution for Science. Microfossils found on Mars. In 1996, scientists announced that a Martian meteorite recovered from Antarctica's Allen Hills region appeared to contain microfossils, tiny, worm-shaped, mineralized signs that life had crawled across the planet's surface some 4.1 billion years ago. Those observations were ambiguous and extremely divisive, provoking debates that persist to this day. But there was an upside. The Allen Hills controversy has fueled so much of the astrobiology field, says astrobiologist Kendall Lynch of the Lunar and Planetary Institute. I feel so grateful to that rock because it's made us think about what we know about life. Evidence discovered. Over the years, Curiosity has uncovered evidence in the crater for numerous organic molecules, the chemical building blocks for carbon-based life forms, and it has spotted signs of ancient hydrothermal activity where heat and chemical compounds mixed with flowing water, creating possible energy sources. The rover has also determined that methane gas in the crater rises and falls as the seasons change, and it has observed occasional massive pulses of the gas, confirming Earth-based observations that have defied explanation for more than a decade. Such a fluctuation on Earth would be a strong sign of beings with active metabolisms. However, none of these observations has so far been linked to biology, and there's always a chance that processes we don't fully understand are mimicking the signatures of life. Most carbon-related processes on Earth's surface are biological, so to try and change our mindset around and think about a world where that might not be true is a challenge, says astrobiologist Christopher House of Pennsylvania State University. Once you get out of the Earth-centric mindset, then you can start to think of these other ways in which Mars might behave. The curious case of Martian carbon. Curiosity's weirdest, most tantalizing observation only emerged recently. In multiple rock samples from various locations in the crater, the rover found organic compounds containing odd ratios of carbon isotopes or atoms of the same element that contain different numbers of neutrons in their nuclei. On Earth, organisms preferred to use the lighter form of carbon in metabolic or photosynthetic reactions, leading to a skewed ratio in which the lighter form is much more abundant than the heavier form. And in 5 locations in Gale Crater, scientists found the same thing. Lighter carbon isotopes were much more abundant than their heavier cousins, relative to what scientists have seen in the Martian atmosphere and meteorites. A mysterious coating on the rocks. NASA's Perseverance rover arrived at the Jezero crater on Mars last year, and it's also on the hunt for signs of ancient life. During its travels through Jezero, Perseverance spied numerous rocks with a purple, iron-rich coating. Purdue University's Bradley Garchinsky, who is studying the coating, says it's unlike anything that rovers have spotted on Mars before, even though rocks with different coatings have been seen on other parts of the planet. On Earth, such coatings are often observed in deserts, where conglomerates of rock-munching microbes thrive. They're intriguing, and they're certainly on Earth of biological interest. So by translation, they are then of great astrobiological interest to us when we see them forming on other worlds, Williams says. Ambiguity from another world. For now, definitive detection of life requires bringing pieces of Mars back to Earth, where scientists can use the most capable instruments available to scrutinize them. One of Perseverance's primary tasks is to identify and collect rock samples for a future spacecraft to send home. The samples we're collecting now, they're being very carefully selected, Freeman says. We know broadly the context that they're coming from. That's going to be key to pulling apart these big questions. The canals on Mars. The canals of Mars have long fascinated astronomers and captivated the imagination of humanity. These enigmatic features, first observed by Italian astronomer Giovanni Schiaparelli in the late 19th century, sparked a debate and speculation about the possibility of intelligent life on the red planet. Although subsequent observations and modern scientific understanding had dispelled the notion of actual canals, the legacy of these Martian channels remains a testament to the allure and mystery of our neighboring planet. Climate of Mars. The climate of Mars is a stark contrast to that of Earth, characterized by extreme cold, a thin atmosphere, and a predominantly arid landscape. Mars experiences a wide range of temperatures, with average temperatures hovering around -80 degrees Fahrenheit, -62 degrees Celsius. However, temperatures can drop as low as -195 degrees Fahrenheit, -125 degrees Celsius, at the poles during winter and reach a maximum of 70 degrees Fahrenheit, 20 degrees Celsius, near the equator during summer. The thin atmosphere on Mars is composed mainly of carbon dioxide, about 95%, with traces of nitrogen, argon, and other gases. The atmospheric pressure on Mars is only about 1% of that on Earth, making it inhospitable for human life without the aid of specialized equipment or habitats. The thin atmosphere also means that Mars lacks a protective shield against harmful solar radiation, making the surface more hostile to life as we know it. As we conclude our captivating journey through the mesmerizing video on life on Mars, we are left with a sense of awe and wonder about the possibilities that await us on the red planet. The dream of finding extraterrestrial life has long captivated our imagination, and Mars stands as one of the most promising destinations in our quest for answers. The tantalizing clues, the tantalizing clues, the tantalizing clues, and the tantalizing clues we've uncovered thus far, from the discovery of water ice to the detection of organic molecules, fuel our curiosity and propel us forward in our pursuit. If you found our video informative, kindly subscribe to our channel so you won't miss out on our videos.